how to interface LCD module, normal LCD module with the controller. Right, normal 16x2 LCD, how will you interface with the controller? So these are few basic types of LCDs available. Nowadays TFT screens are there, that is different. But these are the initial LCD modules available. Basic LCD module available. So this is known as 16x2 LCD. That means 16 characters can be printed in one line. Like that, 2-line displays there. So that is known as 16x2 LCD. This one is 20x4 LCD. That means in each line 20 characters can be displayed. Like that, 4 lines are there. So 20x4 LCD. And this is a graphical LCD. In the old Nokia phones and all you may have seen graphical LCD. Here you will be illuminating the pixels. Here also you are illuminating the pixels one by one. Let us consider the pin diagram of the LCD. Normal 16x2 LCD. Total 16 pins are there in the LCD. This is pin number 1, this is pin number 16. So you can see pin number 1 is ground, 2 is VCC. Pin number 3 is known as the contrast control pin. Contrast control means what? It is a contrast between the background and the pixel when it is illuminated. So when the pixel contrast and the contrast between pixel and the background is less, you will not be able to see the characters properly. Right. So this pin is used for controlling the contrast. How will you control the contrast? You can give a voltage to that pin. Right. So if you are connecting this pin to VCC, it will be having minimum contrast. If you are connecting pin number 3 to ground, it will be having maximum contrast. So what you will be doing means, in the hardware you will be connecting a potentiometer across VCC and ground, and the center pin you will be connecting to VEE, that is a contrast pin. And by adjusting the potentiometer, you can adjust the contrast if required. Right. So when it is connected to ground, it is having maximum contrast. So for simulation and all, we will be directly connecting this to ground. Pin register select pin. Pin number 4 is register select pin. So what is the function of register select? Any idea? So it is used for selecting whether you are going to give instruction or data. But my question is, why do we need to give instruction to an LCD? Data we know, say for example, if you want to display hello world, HELLO, all those characters are known as the data. Right. Those are the data. Why do you need to give an instruction to the LCD or a command to the LCD? What is the reason for that? Data means whatever you are displaying, whatever message you are displaying, that is known as a data. Then why do you need to give command to the LCD? So commands are, say for example, you need to clear the display. For example, so for clearing a display, there is a certain command. For setting the position of the cursor, again certain command is there. So that is why you need to give a command, right? So how will the LCD identify it is a command or a data what you are writing? Because both the data and the command you will be sending to the LCD through this 8 data lines. Either you can send data or command. But how will the LCD processor or controller present inside the LCD identify whether it is data or command? Based on this register select pin. Right. So when you are making this pin connected to VCC, then the controller inside the LCD identify that you are going to send the data. If it is 1, that means you are selecting data. If it is 0, then you are telling the controller present inside the LCD that I am going to send a command. And once command is selected, whatever command you are writing here will be sent to the command RAM present in this LCD controller. If it is 1, then the data you are writing here will be written on to character generation RAM present in the controller of the LCD, not the other controller. LCD controller is there. Right. So if R is equal to 0, whatever you are writing will be sent to the command RAM. If R is equal to 1, whatever you are writing here will be sent to the character generation RAM. So based on the data or command which is received on the corresponding RAMs, the corresponding functionalities will be done by the LCD controller. Right. So that is a function of register select. Then fifth pin is nothing but read bar write. So it is actually read bar write bar. So if this pin is 0, that means you are writing to the LCD. If this pin is 1, that means you are reading from the LCD. So what is the requirement of reading from the LCD? Writing to the LCD is okay. If I want to write hello world, I will be writing the data to the LCD. At what point of time you need to read from the LCD? Generally you are not using that. But what is the functionality of that? Why you are using that? So reading means reading from the LCD, you are using it for identifying the status of the write process, whether the data written is over or not, or you are checking whether LCD is busy or not. Right. So first of all, you need to make read as 1. That means you are going to read from the LCD. Then how will you get the status of the LCD? You need to identify whether it is busy or not. How will you do? How will you see that? You have made it in read mode. Then how will you get the status? You will be able to get it from D7 pin, data line 7 pin. So if it is 1, that means it is busy. 0 means it is ready. Right? 1 means it is busy. 0 means it is ready. So that is the function of read from the LCD. Then pin number 6 is known as the enable pin. So I have told that we are having character generation RAM and command RAM. So whenever you need to write something into these two RAMs, once the data or command, after giving the data or command, you need to give a falling edge to this RAM. That is given through this enable pin. So how will you generate a falling edge there? First you will make enable pin as high for some time, then you will make it as low for some time. That means you are giving a falling edge signal in the enable pin, so that whatever data you have or whatever data or command you have given in this 8 data lines will be latched on to the corresponding RAMs. Right. Generally for a D flip-flop, what you will do, you will give the data, you will give a edge. Right. You will give a falling edge signal generally. That is nothing but the enable. So similarly here, once you have given the data or command in the data lines on the enable signal. That means enable pin you need to write, make it as 1 for some time, then make it as low for some time. That means you are giving a falling edge there. Then the remaining 8 lines are the data lines, where you are writing the data or command. Right. Then pin number 15 and 16 will be the pins for the, what is the function of 16 and 17? It is a VCC and ground for the backlight. This is known as, this green color is known as a backlight. So this is a VCC for backlight. 16 will be ground for backlight. So for easiness, you can remember 1 and 16 will be ground, 2 and 15 will be VCC. Like that you can remember. 1 and 16 will be ground, 2 and 15 will be VCC. So this is the pin diagram of a general 16 cross 2 LCD. Then these are the characters which can be displayed on the LCD. Say for example, I need to display 0. What character I should give? What data I should give? Okay, what data I should give to LCD? 0 0 1 1 0 0 0 0. That is 3 0.
30.
How will you display 1? 3 1.
3 1.
How will you display 2? 3 2. Like that.
32.
So what is this 3 0 mean generally? That is known as a ASCII value of the character. So whatever character you need to display, you need to give the corresponding ASCII value of the character. So for the numerals, you can easily remember the ASCII value, that is 0x30 plus the number you can do. Then you will get the ASCII. So 0x30 plus 2, that is 0x32. That will be the ASCII character of 2. What is ASCII character of 5? 0x30 plus 5. Right. Similarly, what is the ASCII character of capital A, B, C, D, etc.? It is 0x 4 1 onwards. 4 1 is A, 4 2 is B, like that. What is character of small a? That is 5 1 onwards. 5 1, 5 2, etc. I am telling in hexadecimal, not in decimal. So in decimal, for 0 it will be 0x, it is 48 plus 0. Decimal 48 means it is 0, 49 means it is 1, like that. But generally we will be using hexadecimal format. So if you want to say display this bracket, what value you need to give? 2 9, 2 9. Right. If you are giving 0x 2 2 9, you will get this bracket. So similarly, you can find out the corresponding ASCII value of each character you need to display. Then what are the commands that can be given onto the LCD? These are the commands. Some of the commands we will see in the program itself. Right. Say for example, if you want to say if you want to display of cursor off, what is the command? 0x08. That means display will be off, cursor also will be off. That means nothing will be displayed on the LCD. Right. So like these are the examples of commands. Let us take this is the circuit diagram of the experiment what we are going to do. So here pin number, so here I am going to use 4-bit mode of LCD. So for an LCD display, there are two modes of operation known as 8-bit mode and 4-bit mode. In 8-bit mode, we need to give the 8-bit data directly to this 8 data lines. In 8-bit mode of operation, we can give 8-bit data directly to this 8 data lines. But here I am going to show 4-bit mode. What is the advantage of 4-bit mode? Only the higher 4 pins need to be connected. And the rest you need to take care in the program. So here only higher 4 bits or 4 pins you need to connect. So for time being, I am going to show 4-bit mode of operation of LCD. Right. So first to go through the diagram for hardware. I have already told that based on the hardware connection only you are writing the program. Right. So here in my experiment P0.12 I am connecting to D4, 13 I am connecting to D5, 14 I am connecting to D6, 15 to D7. Then P0.4 I am connecting to RS, 5 to R bar W, 6 to enable. Then VCC ground and contrast I am connecting. Right. So here I have shown one potentiometer for adjusting the contrast. But for the simulation, this is not required. Directly VW you can connect it to ground. So maximum contrast will be getting. Right. Then backlight pins are connected. In Proteus, this backlight pins will not be accessible. Directly backlight will be enabled by default. So in Proteus, these two pins will not be visible. Only 14 pins will be there. So these are the steps to print a particular character on the LCD. One by one we will see. So what will be the first step? What will be the first step? We need to make all these pins as output. We need to make all these pins as output. Why? Because you are going to send the data from the arm to the LED peripheral. LED is an output device. So I am going to configure all the 7 lines as output. That is my first step. How will I do that? So I am going to configure P0.12 to 15, that is 12, 13, 14, 15, 12, 13, 14, 15 as that is the data lines D4 to D7 of LCD, and P0.456 we are going to connect to RS, R bar W and enable. So we need to configure all the 7 pins as output. How will you configure it as output? By using IO0 direction register. And what value you need to write to configure it as output? 1. So whenever you are writing 1, that pin will be configured as output. So the corresponding pins I am writing it as 1. So that is FF0. Then second step is I am going to configure something known as function set in the LCD. Function set. What do you mean by function set? In the function set, you are configuring the mode of operation of LCD. I have already told that I am using 4-bit mode. Then I am going to configure the number of lines display I need. I am going to configure it as 2-line display. And what is the font size of the LCD? Font size can be either 5 cross 8 or 5 cross 11 or 8 cross 11 depending upon the LCD. So I am going to configure 4-bit mode, 2-line display and 4 cross 8 font size. How will you do that? So this is one of the tables showing the command or instruction that can be written onto the LCD. Right? So I have already told that whenever you are writing command, RS should be 0. R bar W also should be 0 because you are going to write the command. Then the following is the command, the following is the actual command. So for setting the function set, D7 should be 0, D6 should be 0, D5 should be 1. So these 3 data is fixed, command is fixed. Remaining these 3 bits we need to configure. Right? So by configuring the D4, we are configuring the data length. You are configuring the data length. So if the data length is set as 1, what will be configured here? If we are writing 1, 8-bit data length will be used. That means LCD will be in 8-bit mode of operation. But I have told that I need to configure 4-bit mode of operation. So what should I write here? 0. So it is like this 1 bar 0. You can remember like this 1 bar 0. If I am writing 1, you are configuring 8-bit mode. If you are writing 0, you are configuring 4-bit. So for here, what value should I write? 0. So I have written 0. Then D3 is used for configuring the number of lines in the display. I need to configure 2-line display. So what value should I write here? Either 1 or 0?
1.
Again it is 1 bar 0. So 1 means 2-line display. So here it should be 1, here it is 1. The next one is the font type. So I have told that if we are having 5 cross 11 font size or 5 cross 8 font size. That means 5 cross 11 means 5 into 11 pixels will be there for representing one character. 5 cross 8 means 5 into 8 pixels will be there for displaying a character. So whenever you need to display say 1, only those pixels will be 1, other pixels will not be visible. Right. So here I am configuring 5 cross 8 font size dots. So what value should I write here? 1 or 0?
0.
0. Why? Because again it is 1 bar 0. So for 5 cross 8 I need to write 0. Then the other two can be 0, 0. It is don't care. So what 8-bit value I need to write in order to configure the function set? 0, 1 and 0, 0, 1, 0, 1, 0, 0,
0,
0.
0,
What is
0.
that? 0x 2, 8. So if you are writing 0x 2, 8 to the 8-bit data lines, you are configuring the function set with 4-bit mode, 2-line display and 5 cross 8 font size. Or the third step is you need to clear the display. You are going to initialize the clear the display or clear the display. For clearing the display, this is the command. Directly 0, 0, 0, 0, 1. So what is the command? 0x01. So when I am writing 0x01, display will be cleared. Fourth step is you are going to initialize the cursor to home position. Initialize the cursor to home position. Home position means what? What is that position?
Display.
First row, first column. Two rows are there. First row, first column. That is known as home position. For clearing the initializing the cursor to home, command is 0, 0, 0, 0, 1, 0. Dash it is don't care. I am taking it as 0. So that is 0x02. That is used for initializing the cursor to the home position. Then fifth step is you are configuring another set of operation known as entry mode. It is directly related with the cursor and the display. Cursor and the display. That is known as entry mode. So in this entry mode, you are configuring whether the cursor should increment after displaying the character or it should decrement after displaying the character. Then whether you need to have a display shift or not. Display shift means running display, something like that. So you are going to configure these two in entry mode. So how will you do that? This is a command for entry mode. So 0, 0, 0, 0, 0, 1 is fixed. Then last 2 bits, that is D1 and D0 you need to configure. D1 is used for configuring cursor increment or decrement. D0 is used for configuring display shift or not. So here I told I am configuring cursor increment. So what should be this value? 1 or 0? 1, because you need to have increment. So this value is bit number 1 is 1. Then display shift on or off. What should I do?
Off.
Off. That means this
0.
This bit should be 0. So what is the value? 0, 0, 0, 0, 1, 1, 0. That is 0, 6.
6.
That is entry mode. In the next step, you are configuring display on, cursor off, blink off. Display on, cursor off, blink off. Again command is here. So display on, control, that is known as a command. So it will be 0, 0, 0, 1. Then last 3 bits you can configure. D means you can configure whether display on or off. So here my display should be on. So what should be this value? 1. Display is on. Then
1.
cursor should be, in my case cursor should be on or off. In my case
Off.
I don't need to show the cursor, only the character I need to show. So cursor should be off. So it will be 0. Whether the cursor blinking should be on or off.
Off.
Blinking of the cursor should also be off. So it also 0. So it is 0, 0, 0, 0, 1, 1, 0, 0. That is 0x 0 C. 0x 0 C. That is a command for display on, cursor off, blink off. Right. So now almost all the configuration is over. Then the next step is you need to configure in which line you need to display. or you are going to configure the position of the character where you need to display. So here 0x80 is used as a base address for the first line. 0x30 will be used as a base address for the second line. Right? So if you are writing data to this corresponding address in the character generation RAM, the data from starting from that address onwards, it will be displayed on the first line. From this address onwards, if you are writing, it will be displayed on the second line. Right? So if you want to display a character on first line, first column, what should be this position? First line is shown by 80. First column will be shown by this position. So if I am writing 0x80 plus 1 means in the plus 0 means it will be displaying on the first row, first column. Plus 1 means it will be displayed on first row, second column, like that. So this will be the actual column of the particular character where it to be displayed. This represents the row. 80 stands for first row, C0 stands for second row. Then as the next step, you can send the character to be displayed. You can send the character that is to be displayed. So these are the steps for sending the or configuring the LCD. Then the next thing is that how will you send the character? Because here you have seen the function is LCD underscore command. Here the function is LCD underscore character. So how will you display a character using LCD character function? How will you display a command using LCD command function? That is what you are going to see. So this is a function for writing the command, that is LCD command function in 4-bit mode. These are the steps. The first step is LCD RS, you need to make it as 0. LCD R bar W also you need to make it as 0. So where was RS and R bar W connected? It is 4 and 5. So in IO 0 clear, if you are writing 30 means bit number 30.4 and 5 will be cleared. Only those two bits will be cleared. So you have written 00030. Second step, what you are going to do is you are going to send the command. So I have told that your command is of size 8 bits. But in 4-bit mode of operation, I am only using 4 lines of the display. So by using 4 lines, how will you send an 8-bit data or command? You are going to send 8-bit command or data, but only 4 lines are required. 4 lines are there. How will you send the command or data? You need to split it into 2 nibbles. MSB nibble and LSB nibble. Nibble means 4 bits. So first you need to send the MSB nibble, then you need to send the LSB nibble. Right. So here I am going to split my command into MSB nibble and LSB nibble. And first of all, I am going to send the MSB nibble. So in this step, you are splitting MSB 4 bits of LCD command. So for time being, consider my LCD command is this. Say 49 for time being. Right. From this, I need to split the MSB nibble alone. So how will I do that? How will you split a bit? I have already told. Whichever bit you need to split, those bits alone should be 1, other bit should be 0 and perform AND operation. AND with whichever bits I need to split, that should be 1, other should be 0. Right. So whichever bits I need to mask, it should be 0. Whichever bits I need to have, that should be 1. So that is when I am ANDing with 0x F0, I will get only the MSB, other bits will be 0. Then what should I do? So when I am performing command, this is a command, I am performing left shift by 8. Why I am performing left shift by 8? It was here, then I am performing left shift by 8. Why I am doing like that? Why you are shifting it? in order to take that bit directly given to bit number 12 to 15, because your data lines are connected from 12, 13, 14, 15. But in this case, if you are directly writing this data, to which pins it will be going? How will you write the data? Using IO pin register. Right. So if you are directly writing this data to IO pin register, to which all bits these data will be going to? This will be going to bit number 4,
4
5,
to
6,
7. 6,
7
7.
of port 0 if you are writing IO 0 pin. So if you are directly writing this data, instead of sending the data to P0.12, 13, 14, 15, you will be sending it to 4, 5, 6, 7. So what will happen? 4, 5, 6 you have used for RS, R bar W enable. To those pins you will be writing the data. So what will happen? LCD won't get the data or command, whatever you are writing it won't get. So for avoiding that, you are left shifting it by 8. Right. When you are left shifting by 8, your data will be placed in this position, that is 12, because previously it was here, you are left shifting by 8. So from here, data will be coming here. When you are shifting once, it will be here 2, 3, 4, 5, 6, 7, 8. When you are left shifting by 8, your data will be correctly placed in bit number 12, 13, 14, 15. Then you can write this data directly to IO 0 pin register. So what will happen? This bit will be going to 12, 13, 14, 15. Right? So that means 15 is connected to D7. This is D6, D5, D4. So why I am left shifting by 8 times? Why? Because in my connection, I have made the connection like that. Right. D4 is connected to 12, D7 is connected to 15. So when I am writing the data, you need to write the data to these pins only. For that, you are left shifting the data by 8 units. So I have written the 4-bit MSB to IO pin, the P0.12 to 15. So MSB I have written. Next, what should I do? I need to send the LSB nibble. So before that, what should I do? I have written the MSB. Then what should I do? So I have told whenever you are sending the data, you should give the falling edge signal on the enable. How will I do that? Which is the enable pin? It is P0.6. So that 6 pin you need to set. So enable will be 1. Then you will give some delay. Then you will make it as 0. That means you are generating a falling edge signal. So whatever data I have given in the previous step, that data will be written on to the command RAM because RS is 0. Command RAM which position? MSB nibble position. Next you need to send the LSB nibble. So how will you split the LSB? This was a command. Let us take this as a command. I need to split the LSB. So how will you do that? LSB bits alone should be 1. MSB should be 0. Perform AND. So when you are ANDing, MSB will be masked. LSB will remain as it is. Then what should I do with the LSB bit? How many times I need to shift? How many times I need to shift? I need to shift by 12 units. Why? Because I need to take this bits from 12 to 15. This is from 0 to 3. I need to shift it 12 times. Right? Because this bit, if you are shifting by 1, it will be here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when you are shifting this 12 times, it will come here. You are performing left shift by 12. Why? In order to bring the data to bit number 12 to 15. If the data is here, then as you have written previously, you can write the data to IO0 pin. So now you are writing the LSB nibble, then again you need to give the falling edge in the enable. So how will you give that? IO0 set equal to 40. So P0.6 will be set. Give a delay, it will be cleared. That means you are generating a falling edge. So the lower nibble is also written onto the LCD. So this is how you are writing command to the LCD in 4-bit mode. You need to split the command into 2 nibbles. Then first you need to send the MSB nibble, give the enable. Then write the LSB nibble, give the enable. Similarly, you can write the data also. Till now you are dealing with the command write. The same method you are using for data write also. But what is the difference here? What is the difference between command write and data write? RS will be 1. All the other steps remain the same. So we'll see here. So RS will be 1, R bar W will be 0. So instead of clearing RS, you need to set RS. Then again you are splitting the MSB. How will you do that? And with the 0xF0, left shift by 8. Then you are sending it to the IO pin 0. So MSB you have sent to the IO pin followed by the enable. Then what you should do? You need to split the LSB. How will you split LSB? And with 0x0f. Previously you are ending with 0xf0. Now we are ending with 0x0f. Then left shift by 12 instead of left shifting by 8. So left shift by 12. Then again send it to IO pin, give the enable. So only one difference is there for sending command and data. For command, RS should be 0. For data, RS should be 1. These are the steps for displaying a data. Then you can select a new file, click on this new, paste the program. The program, save it as .c. In the same directory, you need to verify the directory. I am saving it as LCD 4bits.c in the same directory. Then I need to add it into the project. So right click on source group 1, add the files to group, select the LCD program, LCD 4-bit, click on add. After adding, close this window. You have added the project program to the project. Then you can give build. So before giving build, you can previously in yesterday's last class, you have changed the clock frequency. So I am going to change it back to PCLK by 4. So how will you do that? Double click on the startup.h, click on configuration wizard, expand the VPB divider, make this VPB clock to CPU clock by 4. VPB clock to CPU clock by 4. Then you can give build. Previously it was VPB clock equal to CPU clock. For PWM we have made it like that. Now we are changing it back to the default condition. VPB clock equal to CPU clock by 4. So this is the main program. This is the main part. So I am writing. I am calling the function LCD init. What does that LCD init mean? This is the LCD init. So in LCD init, what I am doing, whatever steps I have told. This step you are configuring P0.12 to 15, then P0.456 as output. Then I am giving some delay. Then I am initializing the LCD.
4-bit mode.
0x02 means what? What is the command? Initializing the cursor to home position. 0x02 means initializing cursor to home position. Then 28 means you are performing the, what is that? 4-bit mode, 2-line display, those things. Then 0C means display on, cursor off, blink off. Then 06 means increment on, shift to off. Then your 01 means you are clearing the display. Then last one 0x80 means you are initializing the display to first line, first position. Right. So this was LCD init. Second function is LCD string. What is LCD string? Where is it? This is LCD string. Right. So LCD string, what I am doing? I am going to display the string. So that string pointer I am passing it here. Pointer I am passing it here. Right. And that pointer here I am using the same pointer I am using here. Message of I. Right. So message of 0 will be pointing to what? Message
G.
of 0 will be pointing to first character. Message of 1 will be pointing to second character, like that. So what I am checking here, I will be running this loop until message of I is not equal to 0. That means when you are giving a string, the last character will be a null character, always. Right. So we will be sending the character. If in a string array, if you are passing this as an array, the last character of the string will be always a null character. So you are reading the character until null character is received. So when message of I means it is G. So G will be, you are going to send it to the LCD. So you are going to write the LCD command function. This is LCD command function. What I am doing is, first of all, what I am doing, I am ANDing with FF, then I am left shifting by, I am ANDing with F0, then I am left shifting by 8. Why I am ANDing with FF and here FF? Because I am handling only these 2 bits. Here, this 8 bits only I am going to send the data. In this 8 bit only I am going to send the data. So for time being, I am clearing all the other bits. Right, you are ANDing with this. So I am clearing this without affecting the other. Then I am ANDing with F0, shift 8. So MSB will be sent, MSB 4 bits will be sent. Then again RS will be 1, enable will be made as 1. Right, RS and enable should be 1. Then I am writing R bar W as 0. Right, then after some delay I am making enable as 0. Right, enable 1, delay, enable 0. That means you are giving a falling edge. Then you are going to split the LSB nibble. How will you split the LSB nibble? And with 0x0f left shift by 12. And with 0x0f left bit shift by 12. So again RS will be 1 itself. You need to write it only once. Then also it will work. Then make the enable as 1. Give delay. Make the enable as 0. Then you are incrementing I. So first G will be sent, then O will be sent, like that. Right. So this is how you are sending the string. Then you are sending the command 0xC0. Why? Why C0 you are sending? And how will you send the command? The same method. Only difference is that RS will be, then on this one, LCD command. Only difference is that RS will be 0. All the other things remains the same. Only difference between sending the character or sending the command is this one. RS will be 0. All the other steps remains the same. Right. So here after sending this, I am sending command 0xC0. What does it mean?
Cursor to the second line.
Cursor you are positioning to the second line. Then I am displaying a value. First I am displaying a message. Then I am displaying a value. So I am sending the string again and I am going to print it. So how will you print a character here? Using sprintf function. Using sprintf function, string printf function. Right. So string printf value underscore j. Right. String printf value underscore j. Percentage d j. What is your j? J is your integer. Right. That or decimal. that decimal data you are converting it into a string of value underscore j, right? So the decimal data you are converting it into a string using string printf function, then you are printing it as you are printing a string. Right? So whatever decimal data you are having, either one method is you can display bit by bit. Say if you want to display 100, what you will do? First you need to display 1, then you need to display 0, then you need to display 0. Other method is you can, whatever decimal number you are having, you can convert it into a string using string printf function. So here percentage %d shows that you are going to convert decimal data to a string. Then once it is converted to a string, the same string function you can use it for displaying the string. Then why you are giving LCD command CC? CC means again the next number should be displayed only after this. Right. Only after value of j is 0, then only in that position only the next number should be printed. That is why you are positioning the cursor to CC. Right. So this is a program for displaying some data in the LCD. Now you can open the Proteus. Now you can click on component mode, click on P, search for LPC2148. You can add it. Then you need to select LCD. So you can search for LCD. You can take this LM016L, that is 16x2 alphanumeric LCD. LM016L. So when you are typing LCD, you will get this, or you can directly write LM016L. 16x2 alphanumeric LCD. Double click on this. LM016L. So now you can take the controller, keep it here, zoom it, adjust it to a viewable screen. Then for taking VCC, you can click on generator mode. Click on generator mode, keep it here. Select DC, keep it here. Then connect all these things to the VCC. Then you need to take ground. How will you take ground? Click on this icon, that is terminals mode. Click on this, take ground, keep it here. We have already done all these things, that is why I am going fast. Then double click on this DC source, configure test 3.3. Okay. Then we can adjust the position somewhat like this, because you are going to use P0.456, then you are going to use 12, 13, 14, 15. So you can keep it somewhat like this. Now take the LCD, keep it here. Have you done? You need to connect the VSS. So before that, you will connect the RS R bar W. So RS should be connected to P0.4. P0.4 to RS, 5 to R bar W, 6 to enable. Then D4 to which pin? 12. So this is 12. 12 to D4, 13 to D5, 14 to D6, 15 to D7. Now you can connect the VCC and ground, right? So for LCD, what will be the VCC?
5 volts.
5 volt. So for selecting 5 volt, you can click on this terminals mode itself. For selecting 5 volt, you can click on terminals mode itself. Previously we are taking ground, no? Click on terminals mode, take power. Take power. Power is nothing but 5 volts. Right? Then for rotating it in the anti-clock other direction, right click, give Y mirror. Right click, click on Y mirror, so it will be like this. Right? Then again click on the terminals mode itself, take ground, keep it here. This pin should be ground. Power should be the second pin. This is a power. Y mirror, connect it here. Don't keep it simply near the pin. Here connection is not there. You move it little bit, then make the connection manually. Right. Then make the connection manually. Then connect to the ground. Done. So VSS and VEE I have connected to ground. VDD I have connected to power. Then you can double click on this controller. Configure the clock frequency as 12 megahertz. Click on this program file. Go to your file, show the hex file. Hex file name will be same because it is the same as the project name. You open, then you can give run.